All right, welcome back for just the final slide here. So we just got a couple of examples. Going the other direction now, we want to find the actual height of an object. So we're given the scale. So in the previous examples there from the previous slide, we were looking for scale. Now we know the scale. So this is probably a little bit more into the comfort zone for those that have taken some construction. So it gives us the first ratio. We know that 1 centimeter is 2,000 meters. So it's going to equal something to something, and like I said before, it's always drawing to actual, drawing to actual. So what information can we collect this time? Well, we're looking for the actual height, so it's probably not that. So we need to know the height in the drawing. So again, you need to pull out your ruler, and, oops, didn't want to really do that, so we'll undo those two things. And there's my selection tool, there we go. All right, so here we go. So find the height of the volcano, and I mean we're approximating it. You've had some practice with the measurements. I'm just going to keep it simple. It looks like 2 centimeters to me. So in the drawing it's 2 centimeters. Again, you did this last unit, so what you do is you take the number that's alone in the proportion, divided by its partner, so drawing divided by drawing. 2 divided by 1 is 2. You then take that ratio, or that factor, and multiply by the last number, the number that wasn't used. So it's the same strategy every time. So we now know that the height of this volcano is 4,000 meters, which is probably a little bit on the unrealistic side, but gives you a general flavor for what we're doing. All right. For the nickel, an extremely large nickel here, again, we're given the scale. So we already know the scale is 2.5 to 1, and we're looking for information on the other side. I'm going to encourage you, use the DNA to match things up. So what information can I find? Well, I can measure a nickel. It's right there in front of you. So it looks like from there down to there is 5.5, and that's centimeters. Move my ruler out of the way. So 5.5. So again, same strategy, okay? That anchor chart's there. You've done this how many times? Take the number that's by itself, 5.5, and you divide it by its partner, which would be the 2.5. So that I'm going to have to use the calculator for, and when you do the division there, we get 2.2. You take that ratio and you multiply it by the actual, or the number that hasn't been used, so it's 2.2. So that means that a nickel is 2.2 centimeters, all right, according to this scale. Home stretch here, the last two examples. Here we have another magnification, so it's like the nickel. So it's a magnification. Snail's not that big. If snails were that big, it'd be the scariest damn thing that you'd see coming home at night. All right, so you don't want to have snails this big. So with the scale, 8 to 1. So you have 8 millimeters to 1, and on the other side the proportion looks like that. Again, I'm going to recommend, for the amount of effort, to keep things lined up and put your DNA in. What can we get out of the snail? Well, we can take a measurement from the picture. So, come on, ruler. And there we go. Doesn't matter which dimensions you pull out of the snail because it's all been magnified by the same amount. Looks like 3 centimeters to me. So the drawing is 3 centimeters. So now we are looking for that unknown. So you take what you know, or sorry, you take the number that's alone. So you take the 3 divided by its partner, which would be dividing by 8. 3 divided by 8, 0.375. Take that factor or ratio, multiply it by the remaining number, which magnification is always going to be 1 for us, so 0.375. So our answer would be 0.375, and we're talking centimeters. So apparently this snail is 0.375 centimeters, or 3.8 millimeters, so it's actually not a very big snail whatsoever. It's not nearly as scary as in real life. Finally, last thing, measuring from a map. So you read this off the bottom corner of any map that you grab, and it tells us that we are looking at a scale of 1 to 2100. And we want to know the actual width here of Canada. So, again, drawing to actual, drawing to actual. And then what you'll do, take your ruler, I'm going to flip it around and do a width. So the width of Canada, something like that. So from there to there, so that looks like 4.3. That's in centimeters. Flip the ruler out of the way. So 4.3. So again, you take the number that's by itself, divide it by its partner. So 4.3 divided by 1 is 4.3. Take that factor, multiply it by the number that you did not use. That's the 2100. 4.3 times 2100. 9,030 kilometers is what we're looking at in terms of the width of Canada. So if you are planning on going into any trades, if you're planning on doing any construction, if you plan on going into manufacturing, there are hundreds and hundreds of examples where you'll be working with scale. This is basically what you're doing. Is there a converter for that? Probably an app exists, but nothing that's overly handy. It's just something that you get used to. So if you spend a bit of time doing construction, you'll find a lot of the experienced carpenters are doing a lot of this stuff in their head. Mind you, they're working with a little nicer scale than what I have here, but it's not a sport unless you get hurt anyway, right? So anyhow, that finishes up the scale end of it. Lots of questions practicing with the measurements and the homework there. So if you have any questions, let me know, and then we can move on to the final lesson.